Happy Pi Day! It's 2021 and there are two things we all really need right now, pi and math. Pi, P-I rather than P-I-E, is also math. Yay! Pi is a mathematical constant that defines the ratio of a circle's circumference to its diameter. It's also an irrational number that can't be reduced to a simple fraction, and in decimal representations, it neither ends nor settles into a permanently repeating pattern. Scholars from Greece to China have spent millennia trying to compute pi into an accurate expression for use in calculus and geometry, as well as mathematical analysis using the real number system. It is most commonly expressed as 3.14, which is why we celebrate Pi Day on March 14th every year. This year, we here at the RBML want to share some of our favorite books on the topics of math, geometry, and of course, pi. Let's take a look. Our first example is a 1482 edition of Euclid. We have many editions of Euclid in our library, but this is the oldest. Euclid was an ancient Greek mathematician who is considered by many to be the father of geometry. His book, known as the Elements, presented the mathematical proofs that had been identified up to that time into a single narrative, making it comprehensible to readers of his own time and still useful over 2 millennia later. This is an early printed edition from 1482. European books printed between 1450 and 1500 are known as incunables, which means they were created in the cradle of printing and in the formative era of print technology. During this time, there were two kinds of books being printed, religious works and secular works, often for educational purposes. This volume was printed in Venice, one of the early printing centers on the continent, and because the text is in Latin, it would have been usable for far more readers than if it had been printed in any of the vernacular tongues. This is a great example of a popular educational text being made even more accessible to readers of that time. Our next book is a copy of Brahmagupta and Bhaskara's Algebra with Arithmetic and Mensuration. Brahmagupta was an Indian mathematician writing in the 7th century, while Bhaskara wrote in the 12th, and both of them predated similar work by European scholars such as Sir Isaac Newton by several centuries. Brahmagupta was the first to give rules for the computations of zeros, and composed his text in verse but without proofs, so it's unknown how exactly he derived his results, which do, however, match the work done with proofs by others later. Bhaskara, meanwhile, worked on calculus and its application to astronomy. This is a 19th century English translation of their work by Henry Thomas Colebrook, who is considered the first great Sanskrit scholar of Europe and was the founder of the Royal Astronomical Society. England's own most famous mathematician is, of course, Sir Isaac Newton. Newton is today recognized as one of the key figures of the scientific revolution, with his work foundational to the modern study of physics. His 1687 work Philosophiae Naturalis Principia Mathematica, or The Mathematical Principles of Natural Philosophy, is often referred to more simply as the Principia. This book established what we now call classical mechanics, or the governing theories of objects in motion. The Principia also states Newton's law of universal gravitation and his rules of reasoning and philosophy, the first of which is, we are to admit no more causes of natural things than such as are both true and sufficient to explain their appearances. His analytical methods of reasoning and scientific observation followed the footsteps of Aristotle and Galileo. Next, let me introduce you to Maria Gaetana Egnazia. Egnazia was an Italian mathematician and theologian, and became the first woman appointed as a mathematics professor at university when Pope Benedict XIV appointed her to the chair of mathematics and natural philosophy at the University of Bologna in 1750. Her major work is the Istituzioni Analitici ad uso della Gioventù Italiana, or the Analytical Institutions for the Use of Italian Youth. These two volumes created a math textbook that covered arithmetic, algebra, analytical geometry, calculus, and trigonometry in 1,000 pages. This was a stupendous work of learning that brought together the notable achievements of contemporary thinkers including Newton, Leibniz, and many others. However, her legacy today survives in a funny if problematic fashion. Amongst other things, Egnazia studied a mathematical problem for finding the equation of a bell-shaped curve, which had also been studied by Pierre de Fermat and Guido Grandi. Grandi called the curve the versoria in Latin, which became versiera in Italian. The English mathematician John Coulson, who translated Egnazia's work into English, made an error in which he confused the versiera, or curve, with a versiera, or witch. After Coulson's mistranslation, the curve problem remains even today best known as the Witch of Egnazia. Now let's finish up with my favorite kind of pie, which is pie. We're of course not allowed to have food in our library, but we can look at books about food, and this is one of my favorites. This is Emily Martin's More Slices of Pie from 2008. It is an artist's book made up of several recipe card slices. Books like this like to play with the physical form and rethink how text is presented. This one with the aluminum pan, like those you see in the baking aisle at the store, is just so much fun. Man, I really want pie now. Hey, Cait. How are you celebrating Pi Day this year? Let us know in the comments. And as always, if you have questions about any of the materials you see here today, let us know at askthecurator@library.illinois.edu.